Hello, hi, namaste. I welcome you all to my channel. Myself Raju Hegde. Today we are going to learn about confusion matrix. A confusion matrix or an error matrix is a table which is used for summarizing the performance of a classification algorithm. So we have looked into classification algorithm in our previous video. There we have seen the prediction output is something is like yes or no, true or false. Examples like whether the patient have cancer, positive or negative, email is spam or ham, whether it will rain or not. So there are so many examples like that for the classification algorithm. So in this example we have taken fire emergency alarm, whether alarm goes on or off during the fire. So we'll have a look into the confusion matrix table. So we have two columns. One is predicted no and predicted yes, actual no and actual yes, true negative, true positive, false positive and false negative. Let's look into each terminologies, the definition, like what is true positive is. In case of true positive, if the alarm goes on in case of fire, this is very straightforward. Fire is positive and prediction made by the system is true. Second one is false positive. If the alarm goes on and there was no fire, so system predicted fire to be positive, which is wrong prediction. Hence the prediction is false. So this is wrong. In third case, false negative. If the alarm does not ring, but there was a fire. System predicted fire to be negative. System predicted there is no fire, but there was a fire. So this is also wrong. So in the last case, if the alarm does not ring and there was no fire, system prediction is negative and this prediction was true and there was no fire. So two cases true and two cases false. So in this table, 50 and 150 times system predicted correct and 15 times system predicted wrong. Let's see what we can able to look into from this particular data. So we will calculate the accuracy of the model from this particular data. So accuracy we calculate true positive and true negative. So these two divided by total number of events, in this case 165, and we also calculate error. The error is 1 minus accuracy. Example, in this case 150 is a total yes, that means system predicted correct, divided by total event, so 90% is accuracy, and error rate is 1 minus 0.9, that means 10% error. So error we divide into type 1 error and type 2 error. So in this case, this is type 1 error 1 and this is type 2 error. Type 1 error, system predicted fire to be positive, which is wrong, hence the prediction is false. Claiming something has happened when it has not happened. In type 2, false negative, system predicted fire to be negative, which was false since there was a fire. Claiming nothing when in fact something has happened. So these two are the type 1 and type 2 error. So we also look into precision and recall. what is precision and what is recall. Okay, let me explain you with an analogy. Imagine that is very easy example. Your girlfriend gave you a birthday surprise every year for the last 10 years. One day your girlfriend asks you, dear, do you remember all the birthday surprises from me? To stay on good terms with your girlfriend, you need to recall all the 10 events from your memory. Therefore, recall is the ratio of the number of events you can correctly recall to the total number of events. In this case, 10 by 10, if it is 10 events total and 10 recalls divided by 10 events, that means 10 by 10 you are 100%. If at all you are able to recall only 7, then 7 divided by total number of events 10, that means 70% accurate you are. However, you might be wrong in some answers. For example, let's assume that you took 15 chances, 15 guesses. Out of 10 were correct, 5 were wrong. This means that you can recall all the events but not so precisely. Perfection is not there. So therefore, precision is the ratio of the number of events you can correctly recall, to the total number of events you can recall. Okay, mix of correct and wrong recalls. From the above example, 10 real events and 15 answers, 10 correct and 5 wrong, you get 100% recall, but your precision is only 66.67, say 67%. This 10 by 15. Recall for yes. Now, in our last example, if you see the table once again, true positive divided by actual yes. That means 100 divided by 105. 95% we have for recall yes. And precision yes is true positive divided by predicted yes. 100 divided by 110, that 91%. Similarly, you can calculate recall and precision for no also. Okay, this is all about precision, recall and confusion matrix. This we are using in classification model. Okay, in my next video we will look into bias and variance trade-off. Till then, take care, have a nice day. Thank you.